All right, good evening. I have an explainer for you that started off with a question from one of my friends. She was wondering about how vaccines work and why I am confident in the 3 vaccines that we have, and possibly more coming down the road, that these are important steps to defeating the coronavirus. And so as I was explaining it, I found myself using metaphors from movies, and then I'm like, oh, I should make this a video because those gifs would be kind of fun. And so that's what I'm doing right here. I'm going to try to explain why I am positive on the vaccines, how they work, based on using science fiction and fantasy movies, which incorporate a huge part of my brain. All right, so as I go through, I'd like to explain, the first thing we have to explain is how do viruses work, because vaccines work with the life cycle of the virus. The virus infects your cells and it gets into your cells like it's shown here. Then a lot of biochemical steps happen in the middle. But really what it's doing is the virus uses your cells as a big copying machine. The virus has mRNA in it that will go to your mRNA copying parts of the cells, and it's going to turn those into protein. And it hijacks those ribosomes that make the protein inside your cell. They make more viral RNA, they make more viral proteins, the mRNA and the proteins come together and they make more viruses that go through the cell. And so the important thing is that the virus includes its own RNA inside it. RNA is a natural part of the virus life cycle. It's just a part that's interior to the cell. So when we started to make vaccines, we started to make them out of proteins. Now we're making them out of mRNA, but it's really nothing new, because all we're doing is we're copying what the viruses are doing, because we want to catch the viruses at their own game. Once the virus gets into a cell and it makes more copies of itself, it ends up infecting more cells, making more virus, infecting more cells and making more virus, and this is exponential growth that will soon take over your body if it wasn't for the good guys, your immune system and your immune cells that recognize the shape of this virus. Now these are amazing cells because they can take a virus that they've never seen before, and once they're alerted to its presence, they learn what it looks like. And then they put out an all-points bulletin on it, they search it out, they destroy the cells that have the virus, and eventually they destroy the virus. It all depends on them knowing what the virus looks like. And this is how vaccines work. Antibodies fit the shape of the virus that allow the immune system to latch onto it, that allow the immune system to kick it out of your body, to pull it apart, and to expel it from your body. And this immunity, we didn't know with this new virus how long the immunity would necessarily be. Except I was usually pretty positive on it because the immune system is very good at taking care of these, and it is also taking care of its cousins, the cousins to the SARS-CoV-2 COVID-19 virus, that are the common cold coronaviruses, that they cause some problems, but for most of us, we can handle a common cold because our immune system recognizes the virus and gets rid of it. I was thinking that that same thing looks like it could happen with the coronavirus, the new one. And it looks like we just have a couple of very prominent publications in the past 2 weeks. One from New England Journal of Medicine that looked at hospital workers after 6 months and found antibodies that still work really well 6 months later. And then my favorite one is from a T-cell lab. And my area from grad school is studying how T-cells work. A T-cell lab looked at T-cells, part of the immune system, against SARS-CoV-2, against previously infected people. And they found that even 8 months old T-cells still mounted a robust response that looks like it's entirely protective of the body. So it looks like for most of us, we are able to fight this off if we can just train our immune system, train the good guys to know what the bad guys look like. The bad guys in this case being the coronavirus. Now, a word about the vaccines. You may have heard about their effectiveness. And before they came out, I was saying I really hope that the vaccine will be 50% effective, because that's what we need for a vaccine to work at all. I wasn't sure. Then the first vaccines came out, 95% effective, 90% effective. The third one came out is 65% effective. But even that might be a slight underestimate. Whatever it is, these vaccines look like they're effective enough in real people. When you inject them, they protect against the symptoms of the disease and the disease itself. How do they do that? Well, they do that because the vaccines contain a broken bit of the virus that can't replicate anymore. It looks the same, it has the same surface, so that antibodies can be developed to it, but it can't make more of itself. And so you don't have to worry about the virus taking over your own cells because it doesn't have that machinery. All it has is the surface. It's a whitewashed sepulcher, or it's a hollow sphere. That is what it is. So your immune system is like the police force of your body. It's going to recognize this virus, and the vaccine just has to have a bit of the virus that is recognizable. In the same way that you have this, have you seen this wizard, is supposed to alert the people to what Sirius Black looks like. Because he's a criminal, right? You know, we all need to recognize him. We need to attack him. Actually, if you know the plot of Harry Potter 3, it's more like an autoimmune response than a true immune response, but that's getting ahead of myself. Spoilers. Instead of a "Have you seen this wizard" poster, we have a "Have you seen this virus" vaccine. That's a little bit of the virus, enough to recognize it, enough of its face, but the virus isn't really there. It's just a broken bit of it. And so the bit that's most often used is the most prominent outward jutting part of the virus, which is the spike protein. Coronaviruses are called corona because corona means crown. They look like they have a little spiky crown coming off each of them. The spiky crown is the spike protein. And so you're giving that spiky crown to the immune system and saying, "Have you seen this virus? Go after it when you see it." And it works really well from the tests that we've seen. So the spike proteins are the part of the virus that sticks up, and they're kind of like, if the virus is like the Death Star, it's big and round and scary. It's not nearly as big, actually, but it's very little. But you have the turrets sticking up from it. And in the same way, you have the spike proteins sticking up from the virus. Even more important for the virus, the spike proteins are essential to how it infects the cells, whereas the turrets on the Death Star, they're not essential. Metaphor breaks down. But you get the idea. You get the idea that spatially speaking, the spike proteins give the immune system a good thing to make antibodies against, to latch onto, and to block the virus from going on to doing other things. And so, how can we make a broken virus so that we can show the vaccines, use the vaccine to show the body, what the immune cells, what it looks like? Well, one of the first examples that was given was that we can inactivate the virus. There's chemicals we can add that cross-link the virus together. They basically freeze it up. And it's almost exactly like carbonite, in the sense that Han Solo is frozen in the carbonite. You can still see his face. You can still recognize him. And you can use the carbonite as an example to say, here's Han Solo, find anyone who looks like him because he has clones around the universe. I'm taking this metaphor places where it really shouldn't go. But you have this face in the carbonite and the frozen thing. You can show that to the immune system and it can recognize what the virus looks like. But inactivated viruses, there's some that are being tried in other countries. But in our country, we aren't trying one of those yet because it seems like we should be able to do better. The virus might look different when it's frozen. So it might, just like this face doesn't really look like Harrison Ford, the virus might have a frozen face that doesn't really look like the virus. Or it might be incompletely frozen, and you might even still have a little bit of active virus in there. Not really a high chance of that. We have steps we can take to prepare against that. But you realize you're dealing with the whole virus, and so things can go wrong. So I actually would not want to take an inactivated virus if I had other choices. Thank goodness we do. We have 3 other good choices. So actually the third one coming out the pike is the next most complex one. It's one where you take a virus and you switch the face of the bad virus onto the face of a good virus. And so this is where you do a face transplant or a spike transplant. There's a lot of harmless viruses, and we've found that there are some that are very harmless and the body recognizes them very well. And so the AstraZeneca Oxford virus, which is coming and going to be in arms pretty soon, I believe it's been approved. It might have a few more steps to go through. But what it does is it takes just the spike protein and it puts that spike protein onto a harmless virus spike, and it gives that to the immune system. So the immune system says, hey, that spike protein's bad. I'm going to go after it whenever I see it. And that's one way to get the mugshot of the face of this virus, the spike of this virus, into the body. And the AstraZeneca Oxford virus, like I said, it works 65% well, and that's protection from symptoms. the people were actually protected 100% from hospitalization because those numbers are much lower than symptoms. So that's good enough protection, and that seems like something that I would be glad to take. And so there's an old movie by now. I don't think of it as an old movie, but it's called Face Off. It's a John Woo movie where you actually had John Travolta and Nicolas Cage, and at some point in the plot, very early on, they swap faces. One of them gets the face of the other one. And so it's the idea of a face transplant where you have Nicolas Cage's body with John Travolta's face. You have this harmless virus body with the SARS-CoV-2 face. And the immune system can therefore recognize the face because we're all attuned to recognize faces, right? Your immune system is attuned to recognize virus spikes. But you might have noticed that I'm working my way up to the first two vaccines that are released. I know several people that have had these vaccines already. These are the Pfizer and Moderna mRNA vaccines. And the one thing I want you to remember is that mRNA vaccines are a new strategy, but it's based on old biochemistry. Remember, mRNA is in the virus life cycle. The virus makes it in your cells. So what we're doing is we're giving this thing that the virus would already make if it infected you. But because it's the mRNA just for the spike protein, all it's making is a bunch of copies of the spike protein. So you learn what the spike protein looks like, but the spike protein can't do anything by itself, and it can't infect your cells by itself. It needs all the rest of the virus. And so it's like just giving it the information for what the face of the virus looks like. And that's the important thing. The mRNA is information. It's a string of information you give to the cells. They learn what the virus looks like. The Death Star plans were information. Remember, it was very small, right? You could put it into R2-D2, and then you could send him down to Tatooine. And they didn't take up any space because they were pure information. And this metaphor actually goes pretty deep. mRNA and the Death Star plans are similar ideas. The Death Star plans had the shape of the Death Star, which included a weird part to the shape. It included a vulnerability where the exhaust port was, that they knew where they could attack the Death Star. This is the same exact idea. The mRNA contains the plans for the spike protein, and it tells your cells what the spike protein looks like, and then they know how to attack it. It's all information at this point. It's the only protein that's made is the spike protein, and that's why this feels very safe to me. It's like worries about the mRNA getting into your DNA and replicating or something are a little bit like worries if they were worried that the plans in R2-D2 would somehow get out and infect their minds or maybe infect other droids or something like that. It's just not very possible for plans to do something like that. They'd have to be very complex, and the plans are very simple. So what it is these plans show us the shapes that we need to attack. And that's why, if I have the chance to take one of these vaccines, I will jump at it. If they call me and say, hey, we got some extra vaccines in our freezer, would you like one? I think they should be doing that as much as possible. Because the more immune systems know what this virus looks like, the fewer infections we will have. And so, the mRNA vaccines are very, very cool, but they're not our only hope. Remember that the AstraZeneca vaccine is fundamentally different, and it's based on proteins. So if you're uncomfortable with this new technology, even after I've explained why I'm not uncomfortable with it, it's fine in my view if you wait for the AstraZeneca one. That one should be coming very soon. It's already approved in Britain, I believe. The AstraZeneca vaccine, by the way, is probably better even for younger people. And by that I mean, I'm probably stretching the definition of younger to say people like me. But yes, I mean people like me. I would be fine with taking the AstraZeneca vaccine. It takes longer for the immunity to kick in that case. And it's probably better if you need someone who needs immunity fast, it's probably better to give them the mRNA vaccine anyways. It's less effective, but it's still very effective. And like I said, the evidence is that it's very effective against hospitalization, which is the one thing that is the time point that we're really concerned about, that we want to prevent. And we want to prevent the hospitals from being overloaded. So if you told me in April that, or if you told me in January, that we would need a new vaccine by the end of the year for a novel coronavirus, I would be worried because I hadn't heard of the coronavirus yet. If you told me in April, the darkest days of the coronavirus, that we would have a new vaccine in December by the year's end, I would have been elated, overjoyed, because I would not have believed that we could do it that fast. But there's a lot of people who have put a lot of effort into doing this as fast as possible. And I want to say that it looks like from the data that I've seen that it works. It looks like solid quality data. I have every reason to trust that it's going to work, and it's been tested in a lot of people. And so I believe that this vaccine is something I want to take. I want you to take it. When it's my kids' turn, I want them to take it. They should be deprioritized because they're actually at less danger from this than other people. But the whole thing is that this explainer came from a friend who asked me questions. So if you have more questions, post them in the comments. I'll try to answer them. I might be able to answer like one a week or something like that. But I think that this is important information to get out there. And so, I hope that this helps in some way with you making your decisions about what you put in your body. But I think that this vaccine is, on the whole, on the balance, a good thing that will save lives and protect people. All right, until next time, take care.